Hello everyone, welcome back to another review session. My name is Hazim and today I will be going through the final sample of CSCI 211, which is Object-Oriented Programming in Java. I have this sample right here provided by Professor Muhammad Omari. As you can see, there is a lot of theory questions, there is a lot of error, multiple choice error, no error questions, and what is the output question. And finally, write a code question. But before I start, though, a little bit of a disclaimer that you should read your lectures. Obviously, just the sample is not enough. There's a lot of theory, and the theory is going to be covered completely in the lectures. So go through your lectures, understand them, and then come back to this video as a reference. All right, with that out of the way, let's get started. So, question one, what is the parent class of all classes in Java? Now, as you know, there is a class called object. Object is like a default class. Every class you create in Java will inherit from object, whether directly or indirectly, it will inherit from object. It has a bunch of default methods, such as toString or equals, etc. And all classes will inherit from object. So yeah, that is the answer. Which of these keywords must be used to inherit a class? Now, to inherit a class, use the keyword extends, like so. And to inherit an interface, use the keyword implements. But for the sake of this question, the answer is extends. It's none of these, so the answer is none of the above. And okay, which of these is a correct way of inheriting class A by class B? Right, so to inherit class A by class B, you would say class B, and then the keyword extends, and then class A, like so. Class B extends A, and then obviously the curly brackets. All right. What is the purpose of the super keyword in Java? Now, super is used to refer to the parent class, whether you want to call a method or an attribute or the constructor of the parent class, use the keyword super. You can say super and then open parentheses. This is the constructor. This is calling the super constructor. You can say super dot, and then here you can write a method of the superclass or a method of or an attribute of the superclass. These are all valid. So all of these are actually valid, all of the above. Okay. In Java, an abstract class can have. Now, the difference between an abstract class and a normal class is that you cannot instantiate an abstract class. You cannot say new and then write an abstract class here, for example, A1. This is not allowed in Java. You can have attributes in an abstract class. You can have an abstract method, obviously, and you can have a concrete methods. These are all valid. The only thing that you cannot have or cannot do is create an object out of an abstract class or instantiate it from directly from the abstract class. So none of the above, actually. All right. Which of these keywords must be used to declare an interface? Now, obviously, if you want to make an interface, you say interface and then followed by the interface name. So just, for example, interface A1, that's declaring A1 as an interface. So this is the answer. All right. What is the purpose of the keyword implements in Java? Implements, as I mentioned before, it is used to inherit an interface. So to indicate that a class is implementing an interface. That is the answer. All right. Which of these is not a correct statement? So interfaces contain abstract methods. Yes, that is a correct statement. You can put abstract methods in interfaces. Interfaces cannot be instantiated by a new operator. This is also correct. Just like abstract methods, you cannot instantiate. You can say new and then here write an abstract class or an interface A1, for example. This is not allowed. Assuming A1 is an interface, you cannot do this. So this is a correct statement. Interfaces can be inherited. Yes, obviously it can be inherited. That's the whole point why we create interfaces. So which of these is not correct? None of the above. All of these are correct statements. All right. So in Java, an interface can have only abstract methods because interface can, unlike abstract classes can have all of these, but an interface can only have abstract methods. That's the difference between interfaces and abstract classes. So the answer is abstract methods. All right. What is the purpose of the try block in exception handling? Now, usually you have try, and then here you write the code, and then at the bottom you have catch. And inside the catch block, you write the exception type, and then you write the message or whatever the code you want to implement assuming the error got caught. So inside the try block, there is only the code. Inside the catch block, there is everything else. There is the exception name, the type, the code of the exception, and the message. All of these are in the catch block. So it catches exceptions and handles them. This is in the catch block. Specify the exception type. This is also in the catch block. And the exception message is also in the catch block. All of these are in the catch block. The only thing that is inside the try block is just the code that could potentially hold the error. So none of the above. All right, let's move on. So question 2, we have the following classes. We have class fruit, which is the parent class. So I like to imagine this as a hierarchy. You have fruit on the top, and then you have orange and apple, both of which extend fruit. So you have orange and apple are right under fruit. And then you have pineapple, which extends apple. So pineapple is on the bottom. We have fruit as the parent class. Orange and apple are subclasses of fruit, and then pineapple is subclass of apple. Imagine it as a hierarchy, this being the top and this being the bottom. All right. So here it tries to create an object out of fruit, and it casts the class orange. And here it creates an object out of orange, and it casts the class fruit. So it's the opposite. And the issue here is that when you try to create an object and cast a class for it, you cannot cast a class that is lower than the class being instantiated. So this is the class being instantiated, which is fruit, and this is the class that is being casted, which is orange, right? And when you try to create a new class, the class being casted has to be either the same class or a class that is above it, a superclass. This in this case, orange is a subclass of fruit, so this is wrong. You cannot do this. But in this case, fruit equal new orange, orange is lower than fruit, so this checks out. This is fine. But this is wrong, and the reason this is wrong because technically not every fruit has to be an orange, right? A fruit could be also be an apple, so this is wrong. But here, every orange is a fruit, so it doesn't matter, right? So this checks out. So the whole code is going to give us an error. All right, next one. We have essentially the same thing. Apple equal new pineapple. Now apple is higher than pineapple, so this checks out. This is fine. We have fruit equal new orange. Also, this checks out because fruit is higher than orange. And then it tries to assign apple into fruit. And this, by the way, is called downcasting because apple is casted to apple. And then if I want to downcast it to pineapple, I would do this. Downcast between parentheses and write pineapple. So I'm downcasting from apple to pineapple. And this doesn't generate an error because at the end I'm assigning it to fruit, which is higher than either apple or pineapple. Fruit is from the class fruit, and it is higher, so it doesn't really matter. This is no error. All right. But by the way, if I try to do apple equal whatever downcast is, and then, or for example, without a downcast, if I say apple is equal to fruit, this would be wrong because apple is lower than fruit, so this is wrong, right? But in this case, I'm assigning fruit, which is higher. Fruit is equal to apple. This checks out. This is no error. Okay. Now we have something similar. We have fruit equal new apple. Again, fruit is higher than apple, so this checks out. And then apple equal fruit. Now, apple is less than fruit. Fruit is a fruit, and apple is an apple, right? But I have a downcast. And this is the only way where this could generate no error because I am downcasting it first to apple. So fruit was initially a fruit, and then I'm downcasting it to an apple, and then assigning it to another class called apple, which is also an apple. I know this sounds confusing, but essentially what I'm doing here is I have an object out of fruit and an object out of apple, and I try to assign this object to this object, which is fruit to apple, right? So the issue here, again, you cannot go from high class to low class. So what you have to do is first downcast this class, this object, downcast it to apple, and then assign it to this class in order to keep them of the same level. Essentially, this is what's happening. So yeah, this is being downcasted to Apple and then assign it back to Apple, which will give me no error. All right, let's see this. Now, this is similar to the previous one, but there's no downcasting. So what we do, he creates an object out of orange. This checks out. This is no issue. And then creates it doesn't create, it assigns orange to a class called fruit, right? So fruit is a fruit. Fruit is the higher one. And then I'm assigning orange to it. So I'm going from lower to higher. This checks out. This is fine, right? And then I'm trying to assign fruit to orange. Orange is lower than fruit. So this is wrong because there's no downcasting. If I did do it down, if I said orange equal to, for example, downcasted to orange, like the, and then do fruit with a small f, by the way, this would be the correct way to assign it. But he did not downcast, so this is wrong. He just assigned orange, assigned fruit to orange, but orange is lower than fruit, so you cannot do this, right? So this is error. All right, and finally, here we have the fixed version, which I wrote up here. It is when he did the same thing, create an object for orange, and then we have fruit equal to new orange. This checks out. And then tries to assign fruit to orange, but this time there is a downcast. So as long as I downcast it to any class within the same level of orange or lower, then that checks out. That's fine. This is no error. Okay, so here we have a code and it says select the correct output of the following programs. Okay, let's have a look. So here we have an abstract class called myAbstractClass, and it has an abstract method called myMethod. Okay, and then we have a normal class that implements the abstract class. Now here, notice the keyword implements. We said implements is used for interfaces, not classes. And this is a class, because this is wrong. If this was an interface, right, then this would be correct. But this is a class, not an interface. So you cannot do this. This is going to be a compilation error. All right. Now we use the correct keyword extends, right? And the code checks out. We have a method called myMethod. What it does is it outputs the word extension, right? And then you have the main class, creates an object from that class that we had earlier, and then calls the method myMethod. So this checks out, there is no errors, and is going to call myMethod, which will output the word extension. And yeah, the output will be extension. All right. Here we have yet again the abstract class. It has the abstract method, myMethod, and then we have the same thing essentially, myMethod, the concrete method defined as outputting the word extension. And then again, we create an object, but the difference here is notice how we created an object out of my abstract class. Here we created the object out of my class. And as I said earlier, you cannot create objects out of abstract classes. You cannot use the new keyword with abstract classes. So this is wrong. You cannot do this. It has to be with a normal class. So yeah, this is wrong. This is going to be error. Here we have the same thing again, but notice how there is no implementation for the method, myMethod, like this part. This part is deleted. He removed this part. There is no implementation for the method, myMethod, and it tries to create an object and then call myMethod. But myMethod is not defined. What does it do? We have no idea because it's not defined. So this is going to be well, error, I guess. Yeah. All right, and finally, we have the last one. Here we have, again, an abstract class. It has myMethod, abstract method. It has a normal class, again, myMethod. But notice there is no implementation for the my method, or it's just an empty method. It doesn't do anything. And then creates an object, normal class again, and then calls the method. This checks out. There's no errors here, but my method does nothing. So there's going to be no output. And yeah, okay. Now we have a code, and the question says, what would be the output in the case of the following input values? So it asks for an input right here, I is equal to input.nextInt. And what would be the output if I were to input I is equal to 0 or 1 or 1.1 or 2 or 3? So yeah, let's go through the code a little by little. So we have the main class. We have an array, an int array, and it goes from 1 to 5. So the indexes are 0, 1, 2, 3, 4, right? The indexes go from 0 to 4. And then we have three variables, x, y, z, and I is initialized to 0. All right, everything is fine so far. And then we try to do the following divisions or calls, I guess. We have x is equal to 6 divided by I. So if I would be equal to 0 in case of the first question, this would generate an arithmetic exception. So yeah, that would be the case. But let's continue. 6 divided by I. And then we try to call A of index I. So again, indexes go from 0, 1, 2, 3, and 4. So those are the indexes. You can only call either one of those numbers from the array. And then we have a division of the A of index of I plus 2. So for example, if I was 0, then I plus 2 is 2. So we would call the third number inside the array, right? And then divided by I minus 3. Whatever the value of I minus 3, we do that. Okay. And then we have three catch blocks. Now notice this is inside the try block, and then we have three catch blocks. Inside the catch blocks, we have an arithmetic exception and an array index out of bounds exception, and we have the super class of all exceptions. This will catch any type of exceptions, right? So the arithmetic exception is for when you divide a number by 0, or you do something that is impossible in math, or something that would give you infinity, which is essentially dividing a number by 0. So in case you input I is equal to 0 in here, it will try to do 6 divided by 0, which will generate an arithmetic exception, and it will ignore the rest of the code. It's not going to continue. This is a key thing, right? When you find an error, the code will jump straight to the catch box and try to catch that error. It's not going to continue the rest of the code, right? So we have 6 divided by 0, again, error. It goes down to this catch block, which is the arithmetic exception. What will it do? It will output arithmetic exception caught, right? After the exception is handled, it will continue. It's not going to go back. No, it will continue. This is ignored because there is no index out of bound, and this is also ignored. And we will go to the finally block. Finally will happen no matter what, whether there is an error or not. Finally will always happen, right? And even outside the final block, we have the last code, the last line of code, which is system out program continues with I is equal to whatever the value of I is. This also will always happen because whenever you find an error and it gets handled with the catch block, this catch block has exception. Exception EX is going to catch all types of errors. So no matter what the error is, it will be caught with this, right? So this will also always happen technically because any exception is going to get handled. So again, if I input 0, it will do this. It will generate an error, go to arithmetic. So the first output will be arithmetic, arithmetic, and then exception caught. I'm not going to continue it. Okay. And then it will jump down here. It will go to the final block. It will say finally block and then entered. I'm not going to continue it again, which is this, right? And then you will continue down here. It will say program continues with I is equal to whatever the value of I is 0. So program continues with I is equal to 0. This is going to be the output essentially. Now, if I input I is equal to 1, we have 6 divided by 1. This checks out. There's no problems, and no problem at all. There's a of 1, which is this number right here, which is 2. Also no problem. A of 1 exists, so we can call it. And then we have a of I plus 2, which is 1 plus 2. 1 plus 2 is 3, which is this we call the number 4. So so this is 4 divided by I minus 3. 1 minus 3 is negative 2. So 4 divided by negative 2, which is equal to negative 2. This checks out. There is no issues. So again, none of these are going to happen. We will go straight to the finally block. If I is bigger than 4, I is equal to 4. Well, I is not bigger than 4, I is equal to 1 in this case. So nothing's going to happen. It will just say finally block entered. And again, it will say program continues with I equal to 1. So all the output is going to be finally block entered, and program continues with I is equal to 1. That's going to be the output. All right, so now we have if I is equal to 1.1. So if I try to input 1.1, now keep in mind, I is initialized as int. So it's not a double, it's an int. So if you try to input a double, this will cause an input mismatch exception. Now that exception is not here written in catch blocks, but we have the main exception, which will again catch any type of exception. So when you try to input 1.1, it will skip these. It will skip this arithmetic exception because it's not an arithmetic exception, it's not an array index out of bounds exception, but it is included in the exception class. So this will happen. So the output is going to be exception, what does it say, caught, and then again the final block, and the program continued. Now program continued with I is equal to 0 because it did not apply 1.1 because that's an error. So program continues with I is equal to 0. All right. Now we have what if I input 2, right? So if I input 2, 6 is gonna, well, 2 is an int, first of all, so that's correct. 6 divided by 2 is 3, that checks out. A of 2 is this number right here, which is 3, so that also checks out. And then A of I plus 2, 2 plus 2 is equal to 4. Do we have a fourth index? Yes, we do. It's right here. So it will call number 5. And then 5 divided by 2 minus 3, which is negative 1, which still checks out. So there's not going to be any exception. We will just continue the code with no exceptions. It will just jump straight to finally block, and the program continues with I is equal to 2. And lastly, we have what if I input 3? Again, same thing. 6 divided by 3 is 2, checks out. A of 3 checks out. But this, it calls A of I plus 2. 3 plus 2 is 5. We do not have a fifth index here. We only have 0, 1, 2, 3, 4. I mean, we have 5 numbers, but the indexes go from 0 to 4. We don't have number 5, which is the sixth number. So 5 doesn't exist. So this is going to generate an array index out of bounds exception because the index is out of the boundaries, which is 0 to 4. So this will generate an array index out of bounds. The output will be this array index out of bounds, and then again the finally block, and then lastly program continues with I is equal to 3. And yeah, that's it. All right. And finally, we have the write a code question. And it says that we need to write a couple of classes. Firstly, an interface called printable. We have an abstract class called shape. We have a class called circle. We have rectangle and main class. So to do this, I have VS Code here open. And let's go ahead and create the classes. So we have printable, first of all. So let's do a new file and let's write printable.java. All right, and we have shape, which is an abstract class. So let's do that. We have shape with Java. We have circle. So circle with Java. We have rectangle, and finally main. And main. All right. So let's start with the first one. Printable is an interface. So let's make it an interface first of all. Printable is right here. So we say interface, and then the name of the interface, printable, and then you open the brackets, just like that. And then you write an abstract method called void print. So you say abstract void and then print. You don't need to write the implementation, just write print just like that, abstract, and that's it. That's all you need to do for the printable class. Okay. Now we have an abstract class called shape. Okay, so shape, right? It's right here. And write abstract right here to indicate that it's an abstract class, not a normal class. Okay. And it implements the class printable. So let's do that. Implements printable, just like so. All right. And then it it doesn't implement the method print, so that's fine. It just has an abstract method double get area. So abstract double get area and then parentheses, just like so. All right, that is about it for the class shape. Now the class circle. So let's go to circle. All right. First of all, it inherits the class shape. So let's write extends and then shape. All right. Don't worry about this error. It will be fixed in a second. Okay. So it has an attribute double radius. So let's do that. Double and then radius. Yeah. And where is it? Yeah, defines a constructor circle, and that takes double radius as a parameter. So to make a constructor, we write the class name and then parentheses. You write the parameters, which is double radius, and then the brackets. And then usually you write this radius is equal to radius to indicate that the number inputted here is going to be equal to the radius of the circle. Okay, and then it implements the two methods get area and print. Print should display the circle information, and get area is just returns the area of the circle. Let's do get area first. So it should be double get area, and it returns the area of the circle. Now the area of a circle is obviously pi r squared. So to write pi, you write math.pi and you multiply it by r squared. So you can write radius 2 times, right? Radius times radius, just like so. All right. And print, which should display the circle information. For example, a circle is created with radius and then an area of, and then you write the area. So let's do that. Void print, and then it outputs the following. A circle is created, and then with radius, and then after the string, I would add a plus to indicate that I'm concatenating two strings, and then plus the radius. So I would write the radius here, all right? And then plus another string, and then we continue, comma, and then area of, and then insert the area. So comma, and an area of, and then again plus. To get the area, I will just call the method get area. So I'll just write here get area. And that's it, pretty much. All right, also write public here. Okay, all right. Let's move on to rectangle, which is essentially the same thing, mostly. Uh, we have, first of all, inherits the class shape. Oh, sorry. Inherits the class shape, so extends shape. Okay. And yeah, okay. So has two attributes, double width and double length. So let's do that. Double width, comma, length. Okay. Defines a constructor, again, rectangle with the width and length. So let's do that. We have rectangle. And then it takes double width, comma, double length. All right. And then again, we would have this dot width is equal to width, and this dot length is equal to length, just like so. All right. And then it implements the two methods again, get area and print, the same thing. We will have get area first, or sorry, double get area, and it returns the area of a rectangle, which is essentially just width, return first, return width multiplied by length, which gives us the area of a rectangle, right? And then we also have print, so public void print, and what print does, it's the print method should display the rectangle information. For example, a rectangle is created with width 2, length 3, and an area of 6. So let's just write the same thing. A rectangle is created with a width of, and then do plus, and then width, which is the name of the variable that has the width, and then plus, and then afterwards it says comma length. So let's do that, comma length, and then plus the variable length, and then finally the area, and an area of, and then plus, and then again we use the method get area to get the area of the rectangle. And yeah, there we go. All right, let's move on to main, which is the last class. Obviously in main you're going to have the method main, the public static void main, which is essentially this. You want to memorize this, obviously, because in the exam you're gonna be writing code with your hands on paper. You're not gonna have VS Code. So yeah, memorize all of these. And okay, so it uses the class shape to create an array S of shapes. So let's create an array S of shapes. To do that, the class name shape, and then you put two brackets to indicate that it's an array of shapes. Okay, and then the name of the array, which is S in this example, he said S. Okay, and then equals new, and then again shaped, and this time you will write the number of shapes you want to create. In this case, he said I want 3 circles and 3 rectangles. So in total, I'm gonna have 6 of them. So I'll just define it as 6 shapes. All right, and then again use a loop to add 3 circles and a loop to add 3 rectangles. Now, because he said use a loop, I cannot directly initialize them, all the circles and all the rectangles. I have to use a loop to initialize them. So to help myself, basically, I will create an array that holds all the inputs of the circles and the rectangles. In the circles, I'm going to have the radius as an input. So I'll create an array called, for example, R, which represents the radiuses, and then I will initialize all the radiuses of the 3 circles I want. So let's say I want a circle with radius 1, and a circle with radius 2, and a circle with radius 3. Okay, I can use this in the loop to just call the index of every radius of the circle. And I will do the same thing with a rectangle. I will create an array for width. I'll call it W. And let's say the rectangle is going to have a width of, for example, 1.5 and a width of 2 and a width of, for example, 2.5. All right. And I'm going to have an array for the length. And then again, let's say 3.0, comma 4.0, comma 5.0, just like so. Okay. Now I can go ahead and create it. And you'll see in a moment why I did all of these, because it will be very useful in the loop. All right, now I need to make a loop that creates 3 circles and a loop that creates 3 rectangles. All right, so I will make a for I loop, like so. We have I is equal to 0, I is less than. Now I want to make 3 circles. So I can write either the length of radius, but for simplicity, I will just write 3, which represents the number of circles I want. So I from 0 to 3, so it's going to happen 3 times, right? And then every time I will create a class from this array. So I will do s of I equals new. And then since I'm creating circles, I will call the circle class. And then I will send in the radius. And in this case, the radius is provided here in this array. So I will call r of 1. And in this, or r of 0, sorry. In this case, 0 is I. So I will call r of I. Because every time the loop happens, I will be incremented. So I will call the next one. And then I will be equal to 3. And then I will call the third one, and etc. That's why I created the loop of radiuses, right? I mean, the array of radiuses. And yeah, that's simply, so what's happening here is every time, for every iteration, I create a new object in this array. The first 3 objects are going to be circle, right? There can be 3 circles. And every time I call the respective value or the respective index of the radius. The first time I will call 1, the second time I will call 2, and the third time I will call 3. And there we go. That's it for the circle. Now let's make a loop for rectangles. So again, I want to create 3 rectangles, but the difference is since the first 3 objects are taken, there are already circles here. We have 3 indexes here, right? Let me just write this really quickly. We have 6 indexes, right? So it goes from 0, 1, 2, 3, 4, 5, 6. Okay, so the first 3, oh wait, sorry, it's not till 6, it's still 5. My bad on this one. Yeah, so it goes from 0, 1, 2, 3, 4, and 5. Yeah, so the first 3 are circles. Those are already created. We have a circle here, a circle here, a circle here, and I want 3 rectangles here. Rectangle here, rectangle here, and a rectangle here. So I'm going to start with the index 3 and do that. So instead of writing s of I will write s of I plus 3 because I want to start from the 3rd index, which is the 4th, the index number 3, which is the 4th object in this array. So s of I plus 3 because I want to start from the index number 3 because 0, 1, 2 are taken by circles. Okay, all right. So new, and then I'm creating rectangles. So I will call the rectangle constructor. And then essentially the same thing, r of I, like so. Oh, yeah, sorry, I forgot to, it's not I, it's width and length. So W of I, and then comma, length of I, like so. All right, so every iteration I will call W of I, which is this, the first one, and then I will call length of I, because that's how the constructor is. And yeah, that is about it for the 3 circles and the 3 rectangles. Let's continue. So it says use a loop to display all 6 shapes information. So I will make a loop, and every iteration I will call the method print, which I defined uh, in rectangle and circle, this method, right? Okay, so I will also use a for I loop, and since I want to call the information of all objects, so I will go from 0 to 6, right? And here I will simply call for s of I, for every shape, I will call the print method, like so. And yeah, and then finally it says use a loop to calculate the sum of all 6 shapes areas and display the sum of all 6 shape areas. And to do this, I will create a new variable called, let's say, double total area, and initialize it to 0. This represents the total area of the 6 shapes. And here I will have yet another for I loop, and obviously, oops, obviously goes from 0 to 6 because I want the area of all 6 objects. And for every iteration, I will call s of I and then dot get area. This will give me the area, and then I want to assign it to total area. So I will write total area plus equals the area of every object called, just like so. And yeah, that is about it. And then finally, display the sum of all 6 shapes, all 6 shapes. So the sum of all areas, which is given by this variable. I will just have an output that says the sum of all areas is, and then concatenate it with total area, just like that. Now let's try to run the code, and it should create, there we go, 6 objects. 3 of them are circles with the radiuses 1, 2, 3, and area of 1 pi, 2 pi, and 3 pi. And the rectangle, essentially the same thing, the width and the length and the area. And then it will calculate the sum of all 3 areas or 6 areas and output it right here. And yeah, that is about it. Thank you for watching, and I hope you enjoyed this review session. Thank you so much.